Okay, class, picking up where we left off at, we have parabolas are symmetric. We call the vertical line that passes through the vertex the axis of symmetry. Now we go to the next page for example 3. Now example 3, it says consider the following graph. Now we look here at this graph, it says find f of -2. So we want to find inside of A here, we have -2. So we know typically x goes there. So since we know x goes there, we need to find when x is -2, and then we need to find out what y would equal. Okay, when x is -2, if we scroll down here, that looks as though it would be about -4. So this answer here would be -4. Okay, next we have find f of 3. So now we need to find when x is 3, what is y? When x is 3, y is 0. Okay, so now we go to the next part. We have C. It says find x when y equals -5. Okay, so now we need to go where y is -5. We got y is -5. We have, actually, this should be -2. So we need to go back to A and make that -2. It almost looked like -4 was correct, but it actually was at actually, no, this should be -5. I'm sorry. That should be -5. Okay, now, when we look here where y is -5, x right here would be -2. But there's another point when y is -5, x will be +4. So it'll be -2 and 4. Okay, now we come here to D. It says find x when y is equal to 6. So now we go where y is 6. Now if you notice here, this graph does not go where y is 6 is. So your answer here would be no solution. Because this graph does not hit where y is 6. So your answer would be no solution. Now we come here to E. It says find the y-intercept. Now we know the y-intercept is when x is 0. So we go here where x is 0. We go up here to y, and it's +3. So we will write the ordered pair as 0, 3. Now we want to find the x-intercept. Now the x-intercept is when y is 0. Or with this graph, we can just look where the graph hits the x-axis. It hits the x-axis at -1 and also at +3. So we come down here and we write our ordered pair. We will have -1, 0, and we will have 3, 0. Those are our two x-intercepts. Now we want to find the vertex. Now remember, the vertex is either the highest point or the lowest point. What is the vertex here? It's at 4, right? But that's the y value. What is the x value? 1. So we will write down our vertex as 1, 4. The ordered pair 1, 4. That will give our point, our highest point. And since it's the highest point, that means that it's the maximum. Are there any questions? Okay, so now we're going to scroll down to the next page, or go to the next page. Now we have our cubic function. It's a polynomial function which can be put into the form f of x equals ax cubed plus bx squared plus cx plus d, where a is not equal to 0. A polynomial of degree should be 3. Now, we come here. We have example 3. It says, fill in the table, then graph g of x is equal to x cubed. Now, we know g of x actually represents y. So here on this table where we have y, we can put g of x to let us know that g of x and y is the same thing. So we put in -3. When we put in these negative values, or these values here, we will put them in parentheses. So -3 to the third power would be -27. -2 to the third power is -8. -1 to the third power is -1. 0 to the third power is 0. 1 to the third power is 1. 2 to the third power is 8. Need to scroll up just a little bit. And 3 to the third power is 27. Now, if you notice here, -3 and 3 has the same value. -2 and 2 has the same value. And -1 and 1 has the same value. The only one that does not have the same value is this 0, 0. And that would typically be your vertex value, because everything is basically spanning from 0, 0. So we will plot those points. So we have 0, 0. Let me see, we have -3. And as you all see, the point disappeared from 0, 0. So you have to put that in there. So -3, -27 would be about here. Then we have -2, -8. Which would be here, bless you. Then we have -1, -2, -8. Then we have -1, -1. Then we have 0, 0, which we plotted here. Then we have 1, 1, which would be about here. Then we have 2, 8, which would be here. And then 3, 27. Be about here. So now, as you all see, a lot of my points have disappeared, but you all should have written them down, and they should form a graph somewhat like this. That's just a sketch of it. It should hit every point. That's just a sketch of the graph that you should have. Okay, now it says 4 graphs of typical cubic functions are shown below. What does these graphs have in common? Okay, now if you notice here, all of these tails, you notice all of the tails are going in opposite directions. So that's what they have in common. You can write down tails go in opposite directions. And just for a visual representation, when I say tails, I'm talking about these values here. Basically, these arrowheads. These are the tails. They go in opposite directions. Okay, now, go on to the next page. It says example 4. Let f of x equals 3x minus 4 and g of x equals x squared minus x minus 5. It says find the following and simplify. Okay, so now basically we have f of 4 here. That means that we go to the f of x formula, and wherever x is, we will substitute 4 in its place. So we have f of 4 is equal to 3 times 4 minus 4. We know 3 times 4 is 12, and minus 4 will give us 8. So f of 4 is equal to 8. Now we have g of 3. We'll go to the g formula here. We'll substitute in 3 wherever x appears. So we have g of 3 is equal to 3 squared minus 3 minus 5. 3 squared is 9, minus 3 minus 5. 9 minus 3 we know is 6, and 6 minus 5 is 1. So g of 3 is equal to 1. Now we go here to C. It says x such that f of x is equal to 11. Now basically what this is saying is that y is equal to 11. So we go to this f of x formula. Let me just write that down. F of x is equal to 3x minus 4. Now we go to this f of x formula, but we substitute in 11 for the f of x. So it'll be 11 is equal to 3x minus 4. So we would add 4 on both sides. So we have 15 is equal to 3x. We divide each side by 3, and 5 equals x. Any questions? Okay, so now we go to D. Again, we go to the G equation. We substitute in negative 2 for x. So we'll put in g of negative 2 is equal to negative 2 squared minus a negative 2 minus 5. And as you all see, when I substitute, I put it in parentheses here. So g of negative 2 parentheses squared is 4. Minus a negative 2 will give you plus 2 minus 5. So now, we have 4 plus 2 is 6 minus 5 will give us 1. So g of negative 2 is equal to 1. Now we go here to E. We have f plus g of x. So basically what we want here, we want f of x, and we want to add that to g of x. We want to add them together. So we would take each one of their formulas. So f of x we know equals 3x minus 4. Now we could put that in a parenthesis showing that we substitute in for f of x. And g of x, which we have to go back up here, is this x squared minus x minus 5. So we have x squared minus x minus 5. Now, what we can do is this here. Since there's no exponents, no like terms, no numbers multiplying to the parenthesis, we could drop the parenthesis. Wait a minute. I have a little error here. We could drop the parenthesis and write it down as is. Since this is added, we will write this down as is, so it'll be plus x squared minus x minus 5. Now we just combine the like terms. We will have x squared, 3x minus x will give us a positive 2x. That will take care of these values. And negative 4 minus 5 will give us a minus 9. So our final answer here is x squared plus 2x minus 9. Now if we look here at this next problem, we have f plus g of 2. So basically this is asking us to get f of 2 plus g of 2. So now we would take that same f formula, the same g formula, but wherever x is, we would substitute in 2. So we would have, in parentheses, 3 times 2 minus 4. That would take care of the f formula, plus the g formula. Now we have x squared. We'll put in 2 for x, minus x, which would be minus 2, then minus 5. Now if you notice here, this is adding. So we take care of what's inside the parentheses first. So we have 6 minus 4, plus in parentheses, 2 squared is 4, minus 2 minus 5. 6 minus 4 is 2. Plus 4 minus 2 is 2 minus 5 is a negative 3. And 2 plus a negative 3 will give us negative 1. Any questions?